In this video, I will try to explain the basics of 5G NR numerology. What exactly is meant by numerology? So numerology, denoted by the Greek letter mu, defines the frequency domain subcarrier spacing. Numerology is a combination of both SES and cyclic prefix. Now in 5G NR, multiple OFDM subcarrier spacing is supported. Thus, based on subcarrier spacing, numerology can have a value ranging from 0 to 4. Which are the supported numerologies or which are the supported subcarrier spacings in 5G? The following subcarrier spacings are supported in 5G New Radio. They are 15 kHz, 30 kHz, 60 kHz, 120 kHz, and 240 kHz. Here, 60 kHz subcarrier spacing supports both normal and extended cyclic prefix. In addition, it only supports the transmission of data. 240 kHz subcarrier spacing supports the transmission of only synchronization signal blocks or SSBs. What exactly is the relationship between numerology and frame structure? As you know, one 5G new radio frame has a duration of 10 milliseconds. The duration of a single subframe is 1 millisecond. Thus, one radio frame has 10 subframes in it. So based on the subcarrier spacing, the number of slots in a subframe varies. At 15 kHz, one slot has a duration of 1 millisecond. Thus, one subframe has one slot. At 30 kHz subcarrier spacing, the duration of a slot is 0.5 millisecond. Thus, one subframe has two slots. At 60 kHz subcarrier spacing, the duration of a slot is 0.25 milliseconds. Thus, one subframe consists of four slots. Similarly, at 120 kHz, the duration of a single slot is 0.125 milliseconds. Thus, one subframe consists of 8 slots. How are slots and OFDM symbols related? So in normal cyclic prefix, one slot has 14 OFDM symbols, whereas in extended cyclic prefix, say for 60 kHz, one slot has only 12 OFDM symbols in it. 5GNR also supports the concept of mini slots. So these mini slots were introduced to support low latency traffic or URLLC. A mini slot can have 2, 4, or 7 OFDM symbols in it. Now, why were scalable numerologies introduced at all? What are the advantages of it? One major advantage was to transmit over a larger bandwidth without increasing the number of subcarriers. So by larger bandwidth, say for carrier aggregation with 4ZZ or more than that, or even for FR2, without increasing the number of subcarriers, it is possible to transmit over a larger bandwidth with less cost compared to a traditional, say, fixed numerology such as in LTE. In addition, scalable numerology introduces multiple possibilities for time domain frame structure. It also supports different propagation delays in, say, compared to a large cell or a small cell. So based on the size of the cell, the propagation delay varies, and scalable numerologies helps in mitigating this. That was a brief introduction to different numerologies in 5GNR. Hope you liked it. See you in the next video. Bye.